Welcome all students, staff, and family members to today's STEAM program. I am deeply sorry for not uploading yesterday's video. I had some technical issues with my editor system and the video recording. But if you look on our YouTube webpage, you will see Week 2 Cancer Lecture. That's the video you should watch before you watch this video. To continue yesterday's lecture a little bit more before we get into today's experiment, I want to introduce you to some careers revolving around cancer. Hopefully, some of you are going to like what you see and pursue a career in one of these fields. The first career is a career biology professor. There are some cool things you could do, like have access to modern laboratories to do experiments of your own and prove or disprove theories that you have created. You can pick and choose what research you would like to do related to your field of study. You can also teach about cancer and biology to students interested in the same areas that you. In order for you to be a cancer biology professor, you have to finish college with your bachelor's, master's, and your PhD, your doctorate. So that's over 10 more years of school that you have to do after primary school to become a cancer biology professor. We talked about oncology in our previous lecture. If you haven't watched that, go back and watch over that and see what oncology is. Oncology is the people that actually look at the cancer tissue. As you can see right here, you can see two people. They're in a laboratory and they're looking at maybe some tissue or some liquid that contains some cancer or bacteria, and they're studying it and seeing the characteristics of it. So you can become a research assistant instead of being an oncologist. There are different varieties of research assistants. Oncology research assistant, immunotherapy research assistant, radiation oncology research assistant. So basically what they all do are they research, they get a topic from their company and they research about it and they test in labs if their research is coming back true or false. So they're basically just doing theories and testing if the research that they have is true or not. And they get a hands-on experience with dealing with cancer tissues and researching and testing new remedies that could possibly cure cancer one day. All you need to do to become a research assistant is just finish with your bachelor's or your master's degree at the college of your choice. Engineer. Or you can become a technology engineer who helps build equipment and robots to help treat cancer. Building CT scanners that can detect if any parts of your body contain a tumor or not. So this is another career that assists in the fight against cancer that you can pursue a career in. Now all you need to do to become a technology engineer is just finish 4 years of college and engineering school. Now I know that cancer isn't a very fun topic, but here are some fun facts about tumors that you might want to know. Did you know that tumors can grow eyes and teeth? Isn't that kind of creepy? The teeth are called teratosmas. They only grow on cells of your body that have the highest potential of developing cancer. So not all of your cells are going to be like this, but if one is, then maybe. Here we go, a short video that we're going to watch on radiation and surgery and how cancer cells develop in your body and how they multiply.
We all start life as one single cell. Then that cell divides and we're 2 cells, then 4, then 8. Cells form tissues, tissues form organs, organs form us. These cell divisions, by which we go from a single cell to 100 trillion cells, are called growth. And growth seems like a simple thing because when we think of it, we typically think of someone getting taller, or later in life, wider. But to cells, growth isn't simple. Cell division is an intricate chemical dance that's part individual, part community-driven. And in a neighborhood of 100 trillion cells, sometimes things go wrong. Maybe an individual cell's set of instructions, or DNA, gets a typo, what we call a mutation. Most of the time the cell senses mistakes and shuts itself down, or the system detects a troublemaker and eliminates it. But enough mutations can bypass these fail-safes, driving the cell to divide recklessly. That one rogue cell becomes 2, then 4, then 8. At every stage, the incorrect instructions are passed along to the cell's offspring. Weeks, months, or years after that one rogue cell transformed, you might see your doctor about a lump in your breast. Difficulty going to the bathroom could reveal a problem in your intestine, prostate, or bladder. Or a routine blood test might count too many white cells or elevated liver enzymes. Your doctor delivers the bad news. It's cancer. From here, your strategy will depend on where the cancer is and how far it's progressed. If the tumor is slow-growing and in one place, surgery might be all you need, if anything. If the tumor is fast-growing or invading nearby tissue, your doctor might recommend radiation or surgery followed by radiation. If the cancer has spread, or if it's inherently everywhere like a leukemia, your doctor will most likely recommend chemotherapy, or a combination of radiation and chemo. Radiation and most forms of chemo work by physically shredding the cell's DNA, or disrupting the copying machinery. But neither radiation nor chemotherapeutic drugs target only cancer cells. Radiation hits whatever you point it at, and your bloodstream carries chemotherapeutics all over your body. So what happens when different cells get hit? Let's look at a healthy liver cell, a healthy hair cell, and a cancerous cell. The healthy liver cell divides only when it's stressed. The healthy hair cell divides frequently, and the cancer cell divides even more frequently and recklessly. When you take a chemotherapeutic drug, it will hit all of these cells. And remember that the drugs work typically by disrupting cell division, so every time a cell divides, it opens itself up to attack. And that means that the more frequently a cell divides, the more likely the drug is to kill it. So remember that hair cell? It divides frequently and isn't a threat. And there are other frequently dividing cells in your body like skin cells, gut cells, and blood cells. So the list of unpleasant side effects of cancer treatment parallels these tissue types: hair loss, skin rashes, nausea, vomiting, fatigue, weight loss, and pain. That makes sense because these are the cells that get hit the hardest. So in the end, it's all about growth. Cancer hijacks cells' natural division machinery and forces them to put the pedal to the metal, growing rapidly and recklessly. But using chemotherapeutic drugs, we take advantage of that aggressiveness, and we turn cancer's main strength into a weakness.
Okay, so now that we watched that, tell me something in the comments below that you learned from this video. Was it the part when they talked about this is why it's hair loss, is because hair cells grow so quickly, and when chemotherapy happens, they affect fast-growing cells. So let's talk about the experiment for today. Okay, so today we will be doing an experiment called curing cancer. Okay, so here goes a little bit of information you need to know before we start this process. A cancerous tumor forms when cells are divided many times in an out-of-control way through what we call cell division. It is really more like multiplication. One cell splits and becomes 2. If 2 cells split, the 2 cells become 4, and so on and so on and so on. How many rounds of cell divisions do you think are needed so that one cell grows to more than 1 million cells? Work this out on the board. I'll work it out as well. So let's try to see how many divisions it takes for one cell to multiply itself into 1 million. So let's see how many it takes. So at division 1, we turn 1 cell times 2 equals 2. That's the first one. Now we turn 2 times 2 equals 4. Right? Then we turn 4 times 2 equals 8. 8 times 2 equals 16. 16 times 2 equals 30. 32 times 6 equals 64. 64 times 2 equals 128. 128 times 2 equals 256. So we're at 1, 2, 3, 4, 5, 6, 7, 8, and we're already at 256. So if you did your divisions and did your multiplication, you should have got 20 rounds of cell division for one cell to equal 1 million cells. Okay, so here are the materials that you'll need for this experiment. You'll need drinking straws, disposable paper cups, scissors, a glue gun or glue or any type of glue, popsicle sticks, tape, string, reclosable sandwich bags, a timer, stopwatch, pipe cleaners, note cards, aluminum foil. These are the notebooks that you will receive. I have plenty notebooks for everybody to receive a notebook so they can write down the vocabulary words on here and do their experiments on here. Take any notes on this notebook. Hopefully we'll get these out to you. Soybeans, green lentils. Now if you're allergic to soybeans or green lentils, please let me know, contact me. We will substitute these for something else because these can be substituted. Soybeans and the lentils, the green lentils. These are all the materials that you need for your experiment. The first thing you'll need for the curing cancer experiment first is to brainstorm. You've seen all the materials, so brainstorm with yourself or another person if you're in a group about what materials you'll need and how you're going to construct your device in order to get rid of cancer. Using a piece of paper or your notebook. Now once you have your idea, you can use your materials and start constructing your device. Now once you constructed your device, as you can see, I constructed mine with the cup, and I have pipe cleaner on it so I can hold it properly, and then I have 2 popsicle sticks with aluminum foil at the end with my note cards at the end so I can pick and choose which cells I want. Now you'll get a bag with soybeans. Soybeans are actually going to be the healthy cells, so you don't want to collect your healthy cells. So we'll make these green lentils the cancer cells, okay? Try one to start off with. Let's say we have 10 healthy cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10 healthy cells. Okay, so each trial is going to be 1 minute. Each trial, so you have a stopwatch. So now you can start off. You can start off with any number that you want of healthy cells. You can start off with 10 healthy cells or whatever number of healthy cells you have. So I have 10 healthy cells. So I have 20 cancer cells. So I'll put 20 cancer cells. There's go 20 cancer cells. Any cancer cells left at the end of the trial are doubled before the next round. So if I don't get this 20, then I have to double the remaining that I had. So any remaining that I have of cancer cells, I have to double. You beat cancer when all the cancer cells are gone. You lose if the tumor becomes greater than 100 cells. So if you have more than 100 green lentils, then you lose. And if you remove more than 10 healthy cells, you lose. So I have 10 healthy cells just to start off with. So if I remove all 10 of these, then I lose. 1 minute. And if you beat cancer, good job. Now try again with a larger number of cancer cells. Let's try trial 1. So I have 1 minute to remove as much cancer cells out of my body. So I'm going to start the timer. Okay. Use my device. Try to get as many cancer cells as I can. I got 2 right there. That's 3. I only got 30 seconds left. Dang it, I got a healthy cell. I lost a healthy cell. Okay, that's been 1 minute. Let's see how many I got. So I started at 10 healthy cells. I took 1 out during surgery on accident. So now I have 9 healthy cells. I took 1, 2, 3, 4, 5, 6 of the cancer cells, the green lentils. Or I put them back in my baggie. And now the 20 that I started with, I got 6 out of that 20, so that leaves me with 14 left. So I need 14 more cancer cells. So I'll get 14 more cancer cells. Okay, that's 14 more cancer cells. So now I have 28 cancer cells now. So I'll restart and hit the start button and try to get as many as I can out. Okay, that's another minute. So I'm on trial 2. I didn't get any healthy cells out. That's a good thing. Let's see how many bad cells I got out. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10 out of that 28. So now I got 18 left. So now I got to put 18 more in. So I got 10 here, so I'll put that 10, now I need 8 more. And this goes on and on and on until either you remove all the cancer cells, or you don't have any more healthy cells. You remove 10 healthy cells, then you lose. If you get 100 green lentils, which are the cancer cells, then you lose. But you could try this over and over again. You can actually, if you're careful enough, you can actually reuse your surgical device that you made. You can remove your surgical device and tweak it a little bit so you can get better results. And that's the experiment that I have for today. If you have any questions, please contact me at agarrett@ulpgh.org. We hope to get the supplies to you, so please contact Dr. Rosemary Anderson. That's R. Anderson at propelschools.com. Thank you so much, and see you tomorrow where we're going on a virtual field trip to Cancer Lab.